And what I want to talk about is graphing polynomials. But with just a, with just a little bit of, I guess, extra bookkeeping, it's really not any harder than that activity that we just did that everyone seemed to understand really well. So let me do this example. Hold on here. Oh, I see it. Really exciting video I'm creating here. So let's do this example. Negative x to the fourth plus 3x cubed minus 4x. And what I'm trying to do is I want to graph this. Well, let me say sketch a graph, since it's not going to be like a perfect graph. And like a lot of stuff in this course, it really comes down to factoring. I'm actually not going to factor this for you. So if you don't mind, I'm actually going to skip that step. So let me just tell you how it factors for now. But I'll say step one, factor it. So I'm going to skip the work for that. And just tell you that this factors as -1 times x times x minus 2 squared times x plus 1. Okay. So okay, it's going to be nice to have the factor. Okay, well, so why did I factor this to sketch the graph? Well, there's a bunch of kind of key information I want to maintain in the graph. I don't need all the details. I don't need everything to be perfect. But one thing I definitely want are the x-intercepts, for example. And by factoring it, I can read off exactly what the x-intercepts are. So that's going to be nice. Well, let me just get to maybe, okay, so this is definitely be a multi-page problem here. So let me start a new page just for a second. Let me just kind of tell you everything that we need. So we need the x-intercepts. And we're going to include something called multiplicities with that. So I'm going to say with multiplicities. So I want the x-intercepts. I want the y-intercepts. That's going to be pretty easy, but it's going to be good too. And the final thing I want is the end behavior. And that's the thing I was talking about at the very start of class. That's actually what's happening as x goes like way to the left or way to the right. So as x goes to infinity or as x goes to negative infinity. And this notation you might not be familiar with. It's actually from calculus, but all it means is x is getting really big or x is getting really negative, big in the other direction, basically. So these are the three things I'm going to use to graph. Let me talk a little bit more about, so here's a new slide again. Apologize for all the new slides, kind of like whiplash in your notes, but we're gonna go back to those other ones in a second. Let me first just talk briefly about multiplicities. And that gets into, on the worksheet we just did, whether the x-intercept is a bounce or a cross. So the multiplicity, so if we have, like, for example, x minus 3 cubed, or if you have like x plus 2 to the 4th, these numbers up here, these are the multiplicities. And again, that basically just determines if it's a bounce or a cross. So for example, if it's odd, that's a cross. So it would look something like this. So at 3, we're gonna cross over. And if it's even, like a 4, that's gonna be a bounce. So at -2 here, we're gonna like kind of smooth bounce, but it's kind of a bounce like that. So there you go. That's multiplicities. And then for end behavior, the kind of short version is basically this little chart. So let me go on here. So end behavior. End behavior, like we talked about at the beginning, depends only on the leading term. That's what's going to be important as x gets really big. And basically, what matters is if it's even or odd. So let me do it. I'll do it this way. So even or odd. So just to have a specific example in mind, actually, before I get here. So for this one, so what I'm talking about now with end behavior is this leading coefficient, sorry, leading term, like this x to the 4th. So if that's even, like x to the 4th, your end behavior is basically going to look like this. So the two ends are both going up kind of like that. That's what I've represented here. And the dot, dot, dot in the middle just means like, I don't know what's going on. It could be going up or down in the middle, but on the ends, it's going up. And odd, it's the same thing as going up on the right, but going down on the left. Now, one caveat to that, though, is actually everything gets flipped if it's a negative. So this is only positive term. This is for positive. For negative, everything gets flipped over the x-axis. So for example, these two arms that are going up would be going down for negative. Negative even, and for odd, it would be kind of like this. Now, if you look at everything on this slide that you see here, everything on the smartboard screen, you might think of this as being a lot to remember, but I think once you start connecting it to other ideas, this is a big idea in math, and actually all classes, all academics, the more you can connect ideas together, the simpler and the easier everything gets. So for example, the way I kind of think about this whole slide is really just, going back to even more basic algebra. I know the graph of y equals x looks like this. And I know the graph of y is equal to x squared is a parabola. It looks like this. If you can just remember this stuff, all of this stuff is kind of just variations on this. So any sort of, so like x to the 1 is odd, right? That would be an odd degree, x to the 1. Well, that's going to cross over, right? So that's going to tell you the multiplicity, but it's also going to tell you the end behavior. Look, this is the same end behavior as x to the 1, right? And the same thing for all these even ones. So like every even thing on here kind of looks like x squared, right? This looks like an x squared, this looks like an x squared, and so on. So, you know, it's actually not as much to remember as you might first think. Although, what I might do, get rid of some of this here. Okay, I wonder if I can bring that over to this. That did not work because I thought it was going to remain in the fortune. Okay, well, we can just flip back and forth. Anyway, okay. So what does that mean for this problem? Well, I already kind of referred to this for the well, actually, let me come here. I'm going to just rewrite the function. So it's negative x to the fourth plus 3x cubed minus 4x, which factors as negative 1x x minus 2 squared x plus 1. Okay. So let's start with the end behavior because that's pretty easy. I mean, you can basically just read it off the graph, but it comes from this negative x to the fourth. It's an even degree, so we know they're both going to be pointing in the same direction. But since it's a negative term, it's like a frowny one. It goes downwards. It's going to look like this. So this is the end behavior for this function. Okay, x-intercepts. Well, we've got the x minus 2 right there is going to lead to an x-intercept of x equals 2, right? The x minus 1 is an x-intercept of x equals negative 1. And you might think that's all there is for x-intercepts, but there's one more right here. Don't forget about this one, x just by itself. That's an x-intercept. Everyone think to yourself, what is that x-intercept? Well, it's x equals 0, right? Because you can think of this as an x minus 0 term if you want. X equals 0. That's another x-intercept. But now we can add the multiplicity. So going back here, okay, going back here, we see that an even power is basically a balance, and odd power is a cross. So that's what I kind of want to add to this. This one, this x minus 2 is even. That's going to be a bounce. But this x minus 1, well, there's no power there, but you can always imagine a 1 there. That's odd. That's going to be a cross. And same thing for this x minus 0. You can think of a 1 there. That's a cross. Okay. This gives us all the information we need except for y-intercept. Y-intercept is actually kind of weird on this one for a way I'll just talk about in a second. But to find the y-intercept is actually not too bad. And we've talked about this before. You know, what's the x value of the y-intercept? Well, it's 0, right? Just plug in x equals 0. And when you do that, if you plug in x equals 0, you get minus 0 plus 3 times 0 minus 4 times 0. It's just 0. So, you know, y is not always equal to 0, but sometimes that works out that way. That's the y-intercept. Okay. So now we are ready to graph. So let me actually try this again. I'm going to take all this information I'm going to start a new page. And I wonder if I can. I thought there might be a way to shrink it. I'm going to have to play with this one later. But basically, we want to take all this information and make a graph out of it. I apologize, I can't figure out how to get this all on one screen. Right now, but let's just make some axes and do it here. Okay. So we're now ready to graph. So the first piece of information I like to usually put on there are all the intercepts. So let's get all the intercepts on there. So if you remember, we had intercepts at, I don't remember, 2, -1, and 0, and 0. So over here at 2, over here at -1, and at 0. So we know the graph goes to these points. It's a good start, I think. And then the next thing to do, and if you could watch carefully here, is, I just start on the left and just move your way across to the right for these polynomials as best you can. So, I'm going to start on the left over here. Now I have to follow this end behavior. This end behavior. So I'm going to start in the lower left quadrant, like this. So I'm kind of coming from the left like this. Now this -1 is a cross. So I have to cross through the -1. The 0 is also a cross, so I have to bend down and kind of cross through that. Now I have to get back to the 2, so I have to kind of turn around. And that's a bounce, so I'm going to bounce off that. And then there's this kind of nice natural check to your answer, which is, am I still following the end behavior? Which is going down to the right. And yes, I am. So there you have it. This is a graph of this polynomial. Now, is it a perfect graph? Well, no, but it captures all the key information. So if I go to Desmos and type this in, zoom in a little bit. I think this picture is very similar to what we came up with. So let me stop the recording now.